In this video we're going to talk about histograms, what they are and how to draw them. Before we do that, I want to talk about the difference between a bar chart and a histogram. So bar charts are really for one specific thing, and when you draw a bar chart is when you have got categories. So for example here, this bar chart, the bars represent how many people speak a particular language. So the first column is how many people speak Spanish, and then Chinese, then Hindi, then French, and English. And they're physical things that you're counting. You're counting how many people are in these categories. So on a bar chart, the x-axis, they are not numerical values. So you draw a bar chart, and when you draw a bar chart, you have to have the gaps between the bars. So because they represent different separate categories, they're not joined together. That's a bar chart. Histograms, you have, typically speaking, on the x-axis, you have numerical values. So here you've got 60, 65, 70, 75, 80, and 85, but there are no gaps between the bars. So there are no gaps between the bars. And the reason for that is because the data is what we call continuous data. Because they're continuous data, because they are numerical values, you can have 60.2 or 60.5 or 70.3 or 73.8. You can have any decimal between these numbers here. So that's what we call continuous data. So for example, people's heights, weights, time as well, for example, they can be measured in decimals. Anything that can be measured in decimals, you have no gaps between the bars, and technically speaking, you'll be drawing a histogram. So bar charts are the categories, things like this, where you have typically got words on the x-axis for the different categories, and histograms and that sort of thing are for kind of like when you got numerical values and you can have any decimals between them, so you have no gaps between the bars. That's the difference between these two here. Now, let's actually get into kind of like what a histogram is, but we'll talk about that in a moment. Okay, so at the moment we're not going to draw a histogram. We're going to talk about grouped frequency. So grouped frequency tables, and then we're going to look at drawing just a simple frequency bar chart. Now, if we're going to be technical, it's a frequency bar chart for continuous data. So remember why I said continuous data is things that can be measured with decimals. So I did say that like a bar chart is for kind of like categories where you have words, but we're going to draw a frequency bar chart which for continuous data. So we're not going to draw a histogram just yet. I know it sounds a bit confusing. We're going to get to histograms in a moment. Now, first of all, if we look at this table of data, our first column represents time in minutes, and then our second column represents frequency. Now, these could be people, and these could be the different groups. So for example, it could be like in a particular task that they have to perform, or something they have to learn, or how long it took them to travel somewhere. I don't know quite what the data represents, but this is time and this is frequency. So let's say we've got 6 people in the 0 to 10 minute slot, and then 9 people in the 10 to 20 slot. So these here are what we call groups, or sometimes they're called intervals, or sometimes they're called classes, and I'll be referring to them as classes. And so for example, this class is from 20, that inequality is important, but it's anyone above 20 but up to including 30. So those 8 people, their times could be something like 21.2 minutes or 30 minutes or 26.3 minutes or 20.1 minutes. But if they got exactly 20 minutes, then they'd be in this group, not this group here. Okay, so one thing to note about this table is that the classes are of equal width. So the classes are of equal width. So what does that mean is if you look at the widths, there's literally the number that they range from. I know I said anything above 0, but greater than 0, but we'll ignore that for now. We're just going to look at the numbers. This group has got a width of 10. This group has also got a width of 10, from 10 to 20. This has got a gap of 10, a gap of 10, a gap of 10. So they are equal widths. So when you have a table that's got equal widths like this, then you can just draw a simple bar chart where you've got the frequency on the y-axis and then the time on the x-axis. So the data, this is the data, this is the actual physical data, the things we're measuring, and you just draw a simple bar chart. So you just draw kind of like a bar. So for the first one would be a height of 10 and a width from 0 to 10. So you just kind of just draw that. So I'm just going to do that now. Okay, so here's the kind of like the frequency, the frequency bar chart for this table here, and you can see it's quite an accurate representation of that data here. You've got the largest bar in the middle here, and then kind of subsequent bars are at the correct height. But because these class widths have got this, because they got the same class width, you can just draw just something like this, which is just a straightforward frequency bar chart. But because the data is continuous, so you can have decimals, there are no gaps between the bars. Now, let's look at this table here. Now, first of all, if we look at the table, notice that the class widths are not quite equal. So what I mean by that is the first group, okay, so we've got ages, we've got frequency. There's 28 people who range from 0 to 20, well, less than 20 in years or ages, okay, and 36 from 20 but less than 40. But if you look at the class width, the first group has got a class width of 20. The next group has got a class width of 20, because 20 to 40 is 20. The next group has got a class width of 10. The next one's 20, but the last one is 30. You can see the gap between 70 and 100 is 30. And then 50 to 70 is 20, and then 40 to 50 is 10, and they're not the same. So what we say this is unequal class widths. Now, if you were to draw a straightforward bar chart for this, so if you had frequency going up, and then what's the data, it's ages on the bottom. So if you just did that, this is what it would look like. So this is it here. Now, if you look at this kind of like frequency bar chart on this, it's very kind of distorting really. It doesn't really represent this data accurately. Because if you look at, for example, this middle bar here, it's got a frequency of 20. But if you look at the last bar here, it's got a frequency of 18. But the bars, I mean, this bar here looks massive in comparison to this one here, and the only reason for why that bar looks physically bigger than this middle one is because it's got a bigger class width, but it doesn't have this, but it's got a smaller frequency than this middle one here. So this kind of like frequency bar chart is very distorting. It doesn't give you an accurate representation of the data. It's not quite a good representation of this data here. Now, when you have unequal class widths, you really shouldn't do this. You really shouldn't draw a frequency bar chart because it's not going to represent the data accurately. What you should draw is a histogram. And we're going to talk about what a histogram is now. So we finally kind of got to it. So we're going to talk about what a histogram is. This is not a histogram, but when you have these unequal class widths, when the widths are not the same size, you draw a histogram. So let's talk about how to draw a histogram. First of all, you have to, so by the way, this is the same table, but I've added an extra column. You have to work out something called frequency density in this extra column. So you have to work out frequency density, and I'll tell you how to do that now. So frequency density, you need to remember the following formula. So frequency density, I'm just going to abbreviate it to FD. is equal to frequency divided by class width. So this formula, unfortunately, you need to remember that formula. And it's a really simple formula, but you have to use it in order to construct a histogram. So when you hear the word histogram, you need to associate it with frequency density. And then this is the formula for it. So what we'll do is we'll work out the frequency density for each row. So the first row has a frequency of 28. But the class width, so 0 to 20 is 20. So 28 divided by the class width of 20 is 1.4. So 1.4 is the first frequency density. The next one's 36 is the frequency divided by the class width. So the range, so 20 to 40 is a width of 20 again. That's 1.8. 1.8. The next one has got a frequency of 20 and a class width of 10. 40 to 50 is a width of 10. That's 2.0 or 2. Now, by the way, you don't need to worry about the less than sign or anything like that. Just forget about that completely. You don't need to worry about that at all. It's just numbers. So the next one is 30. So 30 is a frequency, and then 50 to 70 is a gap of 20. So 30 divided by 20 is 1.5. Okay, and the last one is 18. 18 divided by the width is 70 to 100 is a gap of 30. So a width of 30. So 18 divided by 30, what's that? Is that 0.6? I think it is. Yep. Okay, so these are the frequency densities. So just remember that formula. You've got to remember that formula. Frequency density is equal to frequency divided by the class width. You've got to remember this. So please make a note of that formula. So when you hear the word frequency density, frequency divided by class width. Now, to construct a histogram, so we're actually going to draw a histogram now. On the y-axis, you plot the frequency density. So I'm going to repeat that. You plot the frequency density on the y-axis. That makes it a histogram now. And then on the x-axis is whatever data you have, which is, in this case, it's ages. So, and you just draw the bars that have these as their heights. So let's kind of do that now. So here is the histogram drawn. So each bar has the frequency density as the height, and the width is whatever these are here. But if you look at this bar chart now, sorry, if you look at this histogram now, and if we just focus on those two columns again, this column, which is this bar here, sorry, which represents this row. Actually, let's clear some of this annotation now. So if we look at this one, which is this first one here, middle one, sorry, and if we then compare it to the last one, okay, which was this one here, you can see they kind of like look similar in terms of their area. And that's kind of like the thing you're looking at. You're looking at the size of that bar compared to this one here. So this is the last row and so on. And you can see they kind of look similar because their frequencies are very, very similar. But it's a better representation compared to this one here. I mean, this bar here, for example, is massive in comparison to this one here. It's just completely disproportionately sized compared to that, even though their frequencies are similar. But if you look on the histogram, they kind of look like they have a similar area, and that's kind of like what a histogram is all about. It's trying to make the area of the bar is sort of representation of the frequency of how many people are in that group. So kind of like it's to do with the area of that bar. We're trying to make sure that that bar has an area that represents the frequency, and you can see they kind of look similar in terms of their area. So that's kind of like what a histogram is. So a histogram, remember, it's frequency divided by class width, is the frequency density, and what makes it a histogram is if you see the word frequency density on the y-axis, and that's what you plot, that makes it a histogram. And you do that for tables that have unequal class widths. So you don't do it if they have equal class width, because it's kind of pointless then. But if they're unequal class width, so the widths of different sizes, then you do a histogram, and you need to remember that. So they're the three things to remember. So it's unequal class widths, frequency divided by class width for frequency density, and then you plot that, and that's what makes a histogram. Okay, and I hope that's very clear. In the next video, which I'm hoping will be a shorter one, I'll go through kind of like the types of questions you're going to get asked to do with this. So what you want to do now is practice drawing these first before you look at the next video. Okay, thank you for watching.